welcome to the lecture number 24 in the course on noise control in mechanical systems, and I am Professor Sneha Singh from IIT Roorkee. So, we have covered till now various things in this course so far. So, we began with the introduction to this course and noise and sound in general. Then we covered about acoustic fundamentals, because for entering into the field of noise control, the fundamentals of acoustics is definitely required. Then we studied about some of the ways in which the sound, what is sound as a signal and how the sound signal analysis happens for noise monitoring. Then we studied about human response to noise, because sound and the very basic of noise control is that it is harmful for human beings and the humans want to control the noise. So, what is the response of a human being to noise or the sound signal, that was also studied. And then so this is where we had, so far we have covered these kind of key modules, and now we will begin a new module which is on noise measurement and instrumentation. So, before we see what are the key principles and methods for noise control and some of the case studies of noise control, we need to see what instrumentation to use and what kind of measurement techniques are available for noise control engineering. So, the title of this lecture is obviously Equipment for Noise Control Engineering Part 1. So, we will study about the basic equipments, which is microphones, preamplifiers and data acquisition system in this course, in this particular lecture. So, let us see a typical setup for measuring sound signal. So, nowadays we have various kind of advanced and complicated or sophisticated and compact devices that are coming up to measure the sound and display the information in the form of some signal. Okay. So, basically a device is able to measure the sound and display it in some form of signal and some kind of readable values. But traditionally be it any kind of device, essentially it is made up of three sort of components. Whenever sound signals are measured, we have microphone, which is the main acoustic sensor that we use, that senses the pressure and converts it into acoustical signals. Then we have preamplifiers, because as you know that sound acoustic pressure is a very small value compared to the atmospheric pressure. These are very minor fluctuations which are perceived very loud by the human beings. So, whatever signals that are acquired, they are weak in nature and they need to be amplified to come up to a readable value. So, some preamplification is needed, and then we have a data acquisition system which connects all these together, and finally data is acquired and stored in a readable format. So, let us see this these devices one by one. So, microphone, what is it? It is a type of acoustic transducer or sensor. So, what do you mean by transducer? It is any device that converts one form of energy into another form. So, acoustic transducer, what do they do? They convert the sound energy from sound energy to some other form of energy, and then some other form of energy back to sound energy. So, these kind of conversions they can do. So, microphone is one such device. It is an acoustic to electrical transducer. It converts the sound energy that is incident on it into electrical energy. Okay. So, you can see various kind of microphones. This is a typical mic which you must have seen in various kind of events where the host is using a mic. What is it doing? It is amplifying its sound so that the audience can hear them louder. So, what are the basic components of the microphone? You have the protection grid, because the things inside the microphone are very sensitive. They have to they should be able to sense these small and very minute variations in the acoustic, in the pressure, in the fluid medium pressure. So, these extremely small fluctuations they should be able to sense. So, they are very sensitive devices. So, everything has to be protected. So, protection grid is used, and Behind that we have a diaphragm, which is the very main device of a microphone, and we have a back plate, the casing and the insulator. So, what does the diaphragm do? It is the kind of a membrane that is being suspended around its edges, some kind of membrane or sheet. So, whenever the sound is incident, it vibrates the membranes, and the diaphragm then the vibrations of the diaphragm, whatever they are created, they are proportional to the incident sound pressure, and this acts as one plate of the capacitor. So, here there are different techniques of converting sound to electrical energy. One such being use of in the capacitor microphone, the diaphragm, the back, this is one part of the capacitor, this is another part of the capacitor, and the amount of electrical charge or the amount of voltage that is being stored in the capacitor depends on the spacing between the parallel plates of the capacitor. And as the diaphragm vibrates, one plate is fixed, the other one is vibrating, the spacing keeps continuously changing. So, there is a change in the voltage, which is then converted into if you have a circuit that completes this, then you get an electric current, and where the value of the electric current is then going to be proportional to the sound pressure that is being incident on the diaphragm. Then you have the casing, which is enclosing the entire body, and some insulation is also provided, because it's a sensitive device, it needs to be protected from unwanted noise, ambient wind and weather conditions, and various other reflections from the unknown devices. So, what is the working principle of a microphone? Essentially, most of the microphones, they work on the Faraday's law of electromagnetic induction. So, where what happens is that the diaphragm, or there is some kind of, so basically you can see now there are so many microphones that are coming up, but if I have to explain it in a very simplistic way, what happens in literally every microphone is that you have some kind of, some element which vibrates in proportion to the incident sound energy. It could be a diaphragm that is that's like a thin membrane suspended around its edges. Like for example, imagine a drum, when you're playing the drum and the membranes of the drum are vibrating. The same way the sound wave is incident on it, the membrane is vibrating. So, you have some element that vibrates in response to the acoustic pressure that is incident on it, and that vibrations are then converted into electrical current through some mechanism. So, essentially for every kind of microphone, what happens, the sound waves enter the microphone, they hit the diaphragm or the thin membrane, which is very sensitive to acoustic pressure, and based on the amount of acoustic pressure that is applied on that membrane, the vibrations take place whose amplitude is proportional to the amplitude of the acoustic pressure. So, the value of the vibration would definitely correspond to the value of the acoustic pressure. Then you have some mechanism of converting these vibrations to electrical energy. What is that mechanism? It depends from microphone to microphone. We have various kind of microphones. Each of them use some different mechanism to convert this vibration into electrical energy. Then from that conversion to electrical signal is happening, then amplification happens, and finally we get the output electrical signal. So, let us see some of the types of microphone that are used. First one is these are dynamic microphone. It works on the principle of electromagnetic induction. So, while the rest of the components remain the same, what is the difference is what I am illustrating here. So, here you have a diaphragm which is surrounded by a coil. So, this coil acts like a solenoid and it works on the principle of electromagnetic induction, and there is a magnet that is placed. So, whenever the diaphragm is moving, it sort of acts like moving it's. So, whenever what is the principle of electromagnetic induction? When you move a conductor in a magnetic field, it creates electricity. So, here the diaphragm becomes the conductor, and when it vibrates, it is moving in this magnetic field created by this coil or the and then whatever happens, you have the wire circuits. So, the current is generated by this mechanism. Then with the dynamic microphones, what are some of the features? They are more durable and robust in nature, and they are capable of handling very high sound pressure level. So, they are usually used for live performances, vocals in instruments like drums and guitar amplifiers. So, wherever you have to deal with loud noise, high frequency noise, they are less sensitive to such high frequencies, which makes them very ideal for such loud sound sources. The other type of microphone is the condenser microphone. It is also called as the capacitor microphone. So, the very first diagram I showed was of a capacitor microphone. So, here it uses a capacitor or a condenser to convert the sound into an electrical signal. So, you know that what is in the electrical technology, in the basic electrical technology classes, you must have studied about what is a capacitor. It is some means of storing electrical potential. So, this is when you have two parallel plates, with some charge and separated by a certain spacing, they can act as a capacitor and they can store electric voltage. So, here the diaphragm becomes one plate of the capacitor, and then you have a steady and fixed back plate, and so the upper plate is moving, and therefore, the voltage also due to this capacitance is changing. The capacitance changes, and hence the overall voltage that it is storing changes, and then you have some circuit or some means by which we can then tap this into output voltage. So, the overall output current that is created will be, so the current would be proportional to the voltage, and the voltage would be proportional to the capacitance, which then depends upon the spacing between these plates. So, obviously, and the spacing depends on what? The spacing depends on the pressure, the acoustic pressure that is incident on the plate. So, ultimately you get electrical signal which is which corresponds to the variations in the acoustic pressure. These microphones are more sensitive, very highly sensitive, and have a wide frequency response. They are more ideal for studio recording rather than the open air performances and live concerts. They are more used for studio recording, capturing of the vocals, and whenever you need to record the sound in detail. So, more detailed sound, low key sounds, it requires some external power to operate. We also have something called ribbon microphone. So, what happens here is that a thin metal ribbon is suspended in a magnetic field. Again, this also uses electromagnetic induction. So, just like in the previous case where I discussed about it, you had a diaphragm which becomes the moving conductor in the magnetic field, and a coil is creating that magnetic field. Here also you have similar concept. There is some kind of coil which is creating the magnetic field, but you have, instead of a diaphragm, now you have a thin metal ribbon that is suspended in the magnetic field, and it is also as the pressure is incident, the acoustic pressure is incident, the ribbon moves, and the movement of the ribbon then induces electrical current by the principle of electromagnetic induction. Usually these ribbon elements are made of aluminum or other such light metal, and they are bidirectional in nature. So, they can capture the sound both ways. They are more delicate and sensitive to handle because obviously they have these thin metal ribbon element which can very easily get damaged or broken. Suppose when the microphone falls, it can damage the ribbon element. So, they are more delicate and sensitive, but they give a more warm and natural kind of sound recording, often used in studio settings for recording vocals, strings and brass instruments. Okay. Okay, so that is essentially what a microphone is. If you are interested, you can study about microphones in detail. So, these days we also have the piezoelectric microphones where what happens is that we have a diaphragm and there is a piezoelectric element that is in contact with the diaphragm, and by the principle of piezoelectricity the vibrations are then these crystals, they convert the vibrations of the diaphragm into electricity, and various other things which you can take time and study on your own if you are interested, but in this course we will limit our discussion of microphones to this point itself. The second kind of device used in noise control engineering is a preamplifier. So, what is that? It is an electronic device that amplifies the weak electrical signals typically from some kind of microphone to a level that can be processed further by some other audio equipment. So, as I told you that the signals that are picked up by these microphone, they are very weak in nature, because acoustic pressure itself, these pressure fluctuations itself are extremely small. Even you know that the minimum pressure fluctuation that is perceived is 20 micropascals, which is a very small value. And just when you reach 1 pascal, and considering our atmospheric pressure is this much, even 1 pascal is considered as a 93 dB sound, which is very loud. So, they are very minute pressure variations, and hence the signals created are weak signals, and for further processing and readability they have to be amplified into a larger value. So, preamplifier is needed, it converts the weak signals into more readable format. Okay, so, these are the key functions of preamplifier. First of all, amplification of these low level signals. Okay, so, these low level signals from microphones are converted into some line level or strong enough to be processed further. Various preamplifiers also can be used for signal conditioning, where they can shape or condition the signal. For example, they can filter out some unwanted frequencies, they can adjust the signal's tone, add a gain to adjust the volume level, and so on. So, some kind of frequency weighting also you can do, and you can remove the unwanted bits. Then impedance matching, essentially all the devices we are discussing there, these are various mechanical systems. So, these are electromechanical systems, electronic plus mechanical, and we have these signals flowing from one part to another part, and each of these components should be able to offer least resistance to the flow of the signals, so that we can get high quality signals, and for that there needs to the impedance of one part. So, let us say the impedance of the cables of the microphone should match the impedance of the the data acquisition system, which should match with the impedance of the other form of cables that might be connected to some other signal analyzer. So, various components, the impedance of the various components should match, so that we offer minimum resistance to the flow of the signals we have captured, and we get high quality signal. So, that also is sometimes achieved using these preamplifier devices. Then phantom power supply. So, sometimes the preamplifiers are built in such a way that they are devices which have the knobs to control the gain of the signal, and they also are connected at the back with some power supply, and then they are connected to the microphone, which is the sensor. So, they are supplying power to this whole system, and that in the case of the microphone such as the condenser microphone, they need some external power to operate. So, this can be supplied indirectly from the preamplifier. It can be a source of supplying power, and they can be delivered to the device for operation. So, let us see some of the common preamplifiers that are available. So, several types are available, and they have their own features and benefits. In the market you can find all of these kind of devices. Let us see integrated preamplifiers. They are some of the most basic or rudimentary kind of preamplifiers that can be found in the market. So, they are built into the actual amplifiers or receivers, and they offer the very basic functionality, which means that they may not be able to do some advanced signal conditioning or some kind of advanced filtering. They can only perform the basic function, which is whatever signal is being received, add some factor to it, so that the amplitude of the signal expands. Okay. So, if this is the signal that is being received, you have the preamplifier, this basic preamp. So, no other conditioning, but just adding some gain value to convert it into a more signals with a higher amplitude can be achieved. So, usually for example, a kind of integrated preamplifier could be when you have your own loudspeakers. Suppose you have a microphone, you are speaking as a speaker, I have a microphone, I am speaking, and directly the cable of my microphone is connected to some kind of loudspeaker, and I adjust the volume of the loudspeaker. That itself acts as a pre-integrated preamplifier. So, even the amplification provided by these receivers, here the loudspeaker being the receiver to my sound signal, which is playing it back to the audience, that becomes an integrated preamplifier. So, you cannot condition your signal using a loudspeaker, right, you can only adjust the gain. Then we have some microphone preamplifiers. So, in the modern day what happens that many of the microphones, they have preamplification inbuilt within them. So, sometimes you have this microphone and then you have the receiver, let us say some receiver or speaker. So, within the microphone itself you have got some preamplifier inbuilt into this. So, as soon as the signal is received, it is amplified within the microphone and then sent over to the various devices for processing. Then phono preamplifiers. So, this is usually used when you are using these kind of turntables, or you can say record players. Nowadays it is hard to find phono preamplifiers. So, they are specially used for record players, and you can adjust the gain volume of the sound that is playing through this record player, and with the minimum distortion you can hear the best sound possible. Then you have two other kind of preamplifiers. We have the tube preamplifiers and the solid state preamplifiers. In the tube preamplifiers you use these vacuum tubes instead of the transistors, and they are used to amplify the signal, and when this mechanism is used, it adds more warmth and smoothness and more harmonic distortion to the sound, making it brighter while emphasizing even harmonics, and it makes it ideal if you want to hear some kind of vintage sound. Whereas solid state preamplifier, it uses transistors, this does not use transistors, and instead of the vacuum tubes, and it amplifies the signal. So, here what happens, the transistor, they provide a more transparent clean sound with little distortion that handles higher gain signals and is better for instruments like drums or guitars. So, suppose you are making some recording, you want to amplify it, then solid state preamplifier could be best if you want to hear the sound as it is without any added kind of distortion or without any added conditioning. As it is, you want to hear them without any unwanted noise. You can use the solid state preamplifier, which is usually found with most of the musical recording instruments. Whereas with various kind of you have these record players, you have these gramophones and these kind of devices, where sometimes it adjusts the music or it adjusts the sound signals, so that it adds more bass or it adds more harmonic component to it. So, some conditioning is provided here. Amplification plus conditioning happens, and here mostly it is amplification and noise removal. So, no signal conditioning happens. Okay, then we have the standalone preamplifiers. They are one of the most advanced in all the category, and they offer more flexibilities. They have more flexibility, more control than the integrated preamplifiers, and ideal for people who want to upgrade their music system or want to upgrade their sound recording device and wish for more control over the sound. So, here they can provide a lot of options, like they can amplify the signal, they can condition, filter, then various kind of distortions can be added or removed, and various other kind of signal manipulations. So, more options are provided by such preamplifiers. You can manipulate and condition the signals with more options here. Okay, so the third kind of device we want to talk about is the data acquisition system. So, sometimes if you buy a data, sometimes people say that I bought a data acquisition system for my noise control setup, and sometimes so people say that the entire setup, which means including the microphones, the cables, these preamplifiers, this entire setup becomes like a data acquisition system. So, these terms are used interchangeably. So, essentially a data acquisition system is any kind of system that can facilitate the sensors or the transducers to measure a physical phenomenon and convert it into readable signals. So, not just for sound signals, you can have a data acquisition system to acquire thermal signals. So, let us say you are doing a research and making a study of in some kind of heater or heating ventilation system, and you want to see how the heat transfer takes place, you can make use of a data acquisition system which can have you can have some thermocouples for measuring, which can be connected via some wire and circuits into a hardware from which the signals, these heat signals are converted into electrical signals, they are pre-amplified, they are conditioned and converted into some readable output. So, that will also become a data acquisition system. So, basically any system that can facilitate all of this measurement of a physical phenomenon and conversion into a readable output. So, they are used for acquiring, storing, visualizing and processing of that data, and information is collected and to understand this phenomenon. So, in terms of noise control engineering, how does the data acquisition system be inbuilt or integrated with microphone and preamplifier? So, you can have your sensor, which is a microphone, and then you have a DAC device. So, DAC device, which is a short form for data acquisition device. Okay. This is a short form for data acquisition. Okay. So, you have sensors followed by the signal conditioner, sensors, then you have the preamplifiers. I can add here. Post the sensors you have some preamplifiers, but sometimes the preamplifiers are inbuilt into the sensor itself, and then you have some signal conditioner which can be again part of the preamplifier or part of the DAC device, but signal conditioning happens and then analog signals are converted into digital, and this all happens in a DAC device. And then you have some software which then locks the data and creates beautiful visuals to visualize the data. So, the data acquisition system facilitates, first of all, taking the input electrical signals from the sensor, doing some signal conditioning. So, what are the functions it does? First of all, taking in the acoustic signals, you can say the electrical signals from the transducer, because whatever is the acoustic signal, thermal signal or whatever, it gets converted into electrical signals. So, taking in the electrical signals from the sensors, then doing conditioning. Sometimes even pre-amplification and conditioning can be done using a DAC software or a DAC device. So, pre-amplification, signal conditioning, then conversion from analog to digital conversion of the data, and then finally what happens is that processing of the received digital data and creating visual representations, which is so you have a hardware that takes the signals and does this preamplification, signal conditioning and analog to digital conversion. Then you have the software integrated with a DAC device which then processes it and creates these nice visual representations. Okay, so with this I would like to end the lecture, and in the next lecture we will see some of the more advanced devices used for noise control engineering. So, thank you for listening.